Hello class, my name is Kayla McCullough and I'm going to be discussing task analysis. First we have to be reminded of what a task is. A task is a collection of activities that are directed towards the achievement of a specific job objective. They have a clear beginning, middle, and end where the end is directly linked to the goals of the job. Tasks are sometimes involved in an interaction with a technological system such as a computer, car, or airplane, or a simple system such as a pencil and paper, hammer, or a set of instructions. A task analysis dissolves a task into a number of different elements. You can perform various levels of analysis with the task analysis. Task analysis can also describe the relationships among elements within a specific task. The task analysis provides a variety of uses and applications and is flexible and broadly applicable across tasks and different end products. Task analysis can be used to develop training programs, construct evaluations and assessments, and provide characteristics for the initial steps in design processes. For example, in user interface designs, like for computers and mobile devices, task analysis can describe the user's goals, describe the user's tasks, and construct evaluations. During the initial stages of user interface design, task analysis can provide information about the users and characteristics about the system. Another example would be during instructional design. Task analysis provides required knowledge for the learner tasks. Not only is task analysis useful in the initial steps of the design process, it is also relevant for evaluations and follow-ups as more information is learned throughout the design and evaluation of the product. Some more information can be added to the task analysis after designers have observed additional significant data. There are 4 steps to the task analysis method. The first step is to collect data about the task. Data can be collected from archival sources, such as instruction manuals or sets of directions, written by the designers of the task or by other task experts. In some cases, archival data may not be available, like if the task is new or hasn't been analyzed before. In this case, data can be collected through observation of the task. If the task is easily observable, then data can be collected by naturally or freely observing the task in person, or perhaps by video camera. In some cases, it may be difficult to freely observe the task, so a structured or controlled observation must be completed. Cases of controlled observation may be if the task is scenario-related or completed during using a technological system. If it is impossible to observe the task, then an interview with an expert of the task can provide sufficient data. After the data has been collected, terms or elements need to be categorized through lexicon and/or task taxonomy. The task lexicon lists and defines all of the major terms or task components that may be used to describe the task. The definition should be precise and operational. Task taxonomy is a way to categorize or group terms that are semantically similar in complexity, or occur at a similar part of the task. The level of analysis will have an effect on how specific the description of the task will be. After the data has been categorized, the task description should be created. Task descriptions can be created through a narrative or flowchart. All task descriptions use a temporal or broad to narrow sequence. The narrative format is a flow from the overarching goal of the task to each step and sequence to accomplish that goal. The flowchart provides each task step in a box with arrows leading from box to box. The flowchart can vary in complexity depending on the level of analysis, but as the flowchart becomes more complex, it can be more difficult to understand. The last step of the task analysis is to apply an analytical method. There are 5 methods that can be used to analyze the data collected. Each method can provide unique information and multiple methods can be used for the same task. The methods can be broken down into decomposition methods in which the task is broken down from the main goal into sub-goals and task components. Or, the task analysis can be analyzed via recomposition methods in which the analysis creates a task structure from the decomposed description. The first of the decomposition methods is the hierarchical task analysis, or the HTA approach. The format of the HTA is usually a flowchart or table. The table provides the task steps with additional information such as potential errors, consequences, and solution to the errors associated with the specific step. The second decomposition method is based on goals, operators, methods, and selection rules, also known as a GOMS model. Operators are simple actions, behaviors or cognitions that the user performs to accomplish a subgoal. Methods are sequences of operators that usually occur in order. Selection rules are the rules by which the person performing the task can choose for one method over another. In this method, the analyst would identify a goal of each step within the task, as well as the methods and selection rule. The third decomposition approach is the modular analysis. In this approach, modules of each task step are created with additional information added. The modules consist of the sub-goal that the step is designed to accomplish, the action performed during the step to meet the goal, the info needed to perform the action, and the consequence of the action. The first recomposition approach is ProNet. ProNet begins with a task description, which is then used to produce a task step transition frequency matrix. The matrix lists the number of times one type of task step follows another type of task step. The ProNet network can be visualized with task components linked to one another within the matrix. The multidimensional scaling model is the second recomposition approach. In this model, a task transition probability matrix is created based on a task description. Here's an example provided by Gillian in Chapter 11 of the Handbook of Work Analysis. Here you can see that the task of buying a beverage from a vending machine can be broken down into 19 steps. The bold words are the major terms. As you can see, there are 9 major terms that have corresponding subjects after them. The task analysis provides task descriptions at the functional level in this example. This is a simple version of the task analysis and can be easily converted into a full-on narrative or flowchart. There are numerous advantages to using the task analysis method during job analysis. The task analysis can be easily adapted to any task for any goal. Based on the needs of the job analysis, data can be collected in various ways. So if one data collection option is not available, there are a few others that can be used. Additionally, task analysis can be conducted on different levels, again based on the purpose of the task analysis. A more specific analysis may be conducted, or a more basic analysis can be conducted. Overall, this method is flexible and broadly applicable across tasks and goals. Task analysis results can be easily re-evaluated and modified. If a task analysis is completed but more significant information on the task is obtained, the analysis can be quickly and easily corrected. Additionally, the task analysis can provide extensive and detailed data, but this can also be a downfall. There are a couple of disadvantages of using the task analysis. As mentioned before, the task analysis can produce a vast amount of data, and when used in task statements can overload cognitive resources of SMEs. As SMEs get confused or overloaded, there may be decreases in integrator reliability and validity. Additionally, conducting a task analysis is labor and time intensive. Thankfully, there are programs that can automate the data collection, but these programs may be expensive and the analyst may need to be trained to use them. It is important to consider what resources are available within the organization in order to collect data about the tasks. As mentioned in the first step of the task analysis, one will need to collect data, but if certain methods of data collection aren't available, one may need to compensate by using other data collection methods. For example, if the purpose of the analysis is to create a training program for a new position, there may not be very much archival data, such as instruction manuals. So it will be important to collect all of the task information from competent and knowledgeable SMEs. Considering the level of analysis can be important as well, because you don't want to oversimplify your data collection if you need extremely detailed data. There are a few ways task descriptions can be created in terms of language. They may be described by motor performance, on a behavioral level, on a functional level, or in terms of goals. For example, if the purpose of the task analysis is to provide data for training, then it would be best to describe the tasks on a functional level. Once the purpose of the task analysis has been made clear, it will be easier to decide which analytical method to use and how specific to make the task analysis. In essentially all cases, task analysis must be created for that specific task by the task analyst. Fortunately, based on the flexibility and structure of the task analysis, any analyst can create their own unique task analysis based on the need of the analysis. The creation of the task analysis can be time-consuming and labor-intensive, but because the task analysis is being adapted for a specific need, it can provide exclusive information. If an organization does not already have an analyst, it may need to hire a consultant analyst to conduct the analysis or job analysis as a whole.